Hello Walmart team, I am Goutam Verma from Team Terminator, and in this video we will see our projects and idea that is we are submitting for the Walmart Sparkathon 2023. Let's start with the agenda of the presentations. We will first go throughout with the problem statement. We will see the solutions. पागल है क्या भाई, तू क्या कर रहा है? Hello Walmart team, I'm Goutam Verma from Team Terminator, and in this video we will see our ideas and the complete solutions of problems for the Sparkathon organized by Walmart. Let's see the agenda of this presentations. We will first go throughout the problem statement, then we will look into a introductory solution that we build, and we will see the what algorithm we are going to solve this problems and what technology we are using inside of this whole systems, and the workflow diagrams and data flow diagrams, like how both the things will work inside of our systems, and at the end we will see the use cases of this project and product. So the problem statement is majorly belongs to the logistics area, and in this we are going to build a algorithm that will use to dynamically assign a storage slots in a big warehouses. Based on the changing demand patterns, this will help to maximize the space utilizations. It will help the employees to reduce their travel times and minimize the picking errors. It will also improve the warehouse slottings, can lead to efficient order picking, reduce labor cost, and streamline inventory management system. In short, it will help this algorithm or the solution of this problem will help the systems to provide the solution in a better and efficient way, and also in a less time. So the solution for this problem is to implement a system that analyzes historical data and real-time inventory level to dynamically optimize the allocations of product in the warehouses. The systems can utilize the machine learning to predict demand patterns and adjust the slot assignments accordingly. We are going to use the machine learning model in this to understand what are the real-time patterns and historical data leads to market trends, and at which time the things usually get changed, and at what times we need that particular item to be placed there, so that we can easily get that item in less times and maximize the retrievals of data and retrievals of object from the warehouses. So the algorithms we are going to use and the text we are going to use, we will discuss in these slides. So for the text we will use Python, JavaScript, data analysis, machine learning, optimization algorithms, and real-time inventory tracking to optimize where we need to put that particular product. Yeah, exactly. So we will use the clustering algorithm to group product with a similar demands pattern together, and then we will implement a reinforcement learning algorithm to optimize the slot assignments based on factors like demand changes, product dimension, size of product, and the current market trends, somewhat like this. So our algorithms majorly focuses on these things. So for the algorithm implementations of dynamic warehousing slots, we will first input the historical order data, product attributes, warehouse layouts, like how our warehouse looks like, and the structure of our warehouse layouts, and zone if the zones are actually available inside of warehouse or not. And as the output, we will get the updated slots assignments, like the place from where we needs to put that particular product. So first process includes the collecting of data and pre-processed data. Second will include the demand pattern analysis, and third include the slot assignments initialization. We will finally assign the slots to the product. And fourth is like loop. We will continuously monitor the trends. If we find any major patterns and major flicks inside of our systems, we will reassign that particular product to another another slots if we not require product anymore for a long time. So this involves in the loop and the continuous monitoring for that particular product. So the fifth will looks like the slot optimizations. At this process we will use the reinforcement learning and genetics algorithms for better optimizations of the slots. And at the sixth steps, we will finally update the slot assignments and let the employees know that please we need to change the place of that particular product, because this particular product are no longer in use for 3 to 4 months, and we need to place some another product in at this place so that we can easily retrieve that product whenever we need. And fourth one is periodic refinements, and that is completely option at this moment, because it involves the retrain the RL agents using the updated historical data and demand patterns, and it also include the fine-tune hyper patterns to improve the coverage and performance. So this step is optional, and if we are like having this six steps in our systems, we will able to dynamically allocate the any slots to our product, and the final output will looks like the returning the updated slots and the finally end of the algorithms. So this is how our dynamic warehouse slotting algorithm will looks like. And the workflow of this systems is basically we will collect and prepare the data and perform demand the pattern analysis. Then we will initialize slot assignments. We will loop for continuous monitoring to check whether the this product is required for long-term periods or not. In this, it will involve the monitoring real-time order data, detecting significant demand changes, and if demand change is detected, we will process to the slot optimization and reassign the slots to that particular product. And the fifth one will include the optimized slot assignments. This will involve the appliance of the reinforcement learnings and genetics algorithms, and again we will update the slot assignments. And the fifth one is like the final one is output with the updated slot assignments. So this is the majorly workflow of our algorithm for assigning a dynamic warehousing to the product. And as the data flow involve the data collections, pre-processing, we first needs to pre-process our data, like historical data. Then we need to identify a demand pattern analysis. For identifying a demand patterns, there are lots of libraries and tools are available. We can easily do that by using the noise and the Spotify libraries. And like in the third one, we will use the slot assignment initializations, and we will reinforce the learning for slot optimizations. And then again we real-time slot assignment updation is involved, the algorithm iterations and refinement periodic involved, the implementations and integrations is involved again for the continuous building of applications in a sustainable manner. And then we finally monitor and KPI involvement is involving. So this is like these are the major overview and brief structure of our problem and solutions, how we will implement this algorithms to solve the problem that usually occurs in big warehouses, and how we can solve this by using the dynamic allocations of by using dynamic allocations methods. And by this way we can minimize the time travel cost and also minimize the time which is taken to like process of complete parcel process from taking the items from the warehouses to delivering it to the users. So yeah, this algorithm will definitely bring a great impact to the systems of logistics. And the use cases for the systems will look like it's supposed to be predictive model that detects a sudden increases in social media activity and related to the product. The system sends an alert to the warehouse team and promote them to increase the inventory levels for that product that meets the potential requirements. And yeah, that's all about this. And this is me, the Goutam Verma, and my partner, co-developer Samarth Sharma. Thank you for watching this video. I hope I get a chance to demonstrate you guys live at 25th of August, and would love to discuss this idea in brief and in detail with